This recording is from Jordan High School Secondary 1 Math, and it's about growth and decay that we've been talking about when we're talking about exponential equations in real life situations in class. Okay, if you remember, we've been talking about two formulas that we've been using on exponential growth or exponential decay. And the two formulas are written here. A equals P, parentheses 1 plus R raised to the T power. And that's the exponential growth. On both equations, you use the same things, except one is a plus, one is a minus. You still use A to mean the total. P would be your beginning amount or your principal. Your rate is the R, so like interest rate or decreasing rate. And the T, of course, is time. And you just decide by looking at the problem which formula you use. If you're growing, then you use the growth. If the value is going down or decaying, then you would use the decay formula. So if we look at the first one, we've got exponential growth because things are increasing at an exponential rate. And on our assignment, everything is bank account deposits for this assignment. So you're going to deposit $2,400 in an account that pays 10% interest compounded yearly. So we know that we're using exponential growth, so A equals P times 1 plus R to the T power. Okay, so what do we know? Well, we know that we are looking for the balance, so we don't know the ending number. We do know that we began with $2,400. We do know that our rate is 10%. Calculators don't necessarily like percent, so we tend to put them into decimal form. And then the T is going to be either the 3 or the 7, so let's start with the 3. After, you can go to the 7 and just put it in and still do the same calculations, but instead of the 3, use the 7. So I have $2,400, and I'm going to add 1 plus 0.10 gives me 1.10, and I'm going to raise it to the third power. So when I raise it to the third power, I keep this $2,400, and after I multiply, I'm going to get 1.331. Then when I multiply those two together, the 2,400 times the 1.331, I should get 3194.40. And that would mean, in money, $3,194.40 is my balance after 3 years. And then when you want to figure out the 7, you put a 7 in there instead of the 3 and do your calculations. Now, try this one by yourself. Read the problem and then pause. And then after you've solved it, push play again and see how well you did. So pause now. Okay, let's hope you've tried it on your own. If you're stuck, then I guess you haven't, but that's okay. P is the amount you put in at the beginning, 1 plus, and then R is the rate, which is 7%. So we call that 0.07, and we're going to raise it to the 9th power because it's 9 years. that's the hard part, is just getting everything written in. Now we just do some calculating. Okay, so we'll put the 1 plus 07 together as 1.07, and then order of operations tells us to do our exponent first, and so that's going to give us 1.838. When I multiply them together, I'm going to get 2389.99. And then there's a 6 in there. Now this tells us, because it's money, we only need to the penny. And this is one extra, so I'm going to have to round back, round back, round back, round back. So I actually end up with 2390.00 after 9 years. So that tells us that I put $1,300 in an account. I left it alone for 9 years, and when I go back, it is now grown to $2,390. Now, exponential decay, remember, is the formula you use when something is losing value or decaying. And our decay formula, of course, is the same as before, except you use a subtract sign, a minus sign. So you just go along and see what you know. Valued at $15,000, so that's the beginning price. It depreciates, and that tells you that you're using the decay, so 1 minus. The rate is 12%. Remember to put it in decimals. And the time is 8 years. So the only thing we don't know then is the total, which is what it asks us to look for. Okay, so let's do parentheses first. So I'm going to take 1 and subtract 0.12, and that gives me 0.88. And then if I raise that 0.88 to the 8th power, because order of operations says you do exponents next, I'm going to get 0.3596. Then when I multiply those together, I would get 5394.52, and that means the car, after 8 years, is worth $5,394.52. So its value went down from $15,000 to $5,394.52 after 8 years. So now it's your turn to try. Again, pause the video, try it on your own, and then turn the video back on and check and see how you did. So let's try it ourselves. We know it is depreciating, so we know which formula to use. Find the value of the car means we don't know the value to start with, or to end with. We know it started with $25,000. It's going to depreciate at 9%, so 1 minus 0.09, and the time is 4 years. So the first thing I will do is take using the order of operations again, we would take 25,000. In parentheses, 1 minus 0.09 would give you 0.91 to the 4th power. Again, order of operations tells us to do the exponent, and 0.91 to the 4th power is 0.6857. And then I multiplied that. You just get a times 25,000, and I end up with 17,143.74, which is of course money, and it's the value of the car after 4 years. Okay, now use the steps that you've learned and finish up the worksheet. Remember to choose the correct formula first, fill in the numbers that you know, and then use order of operations to complete it. Good luck.